Hi, Dr. Graham Blackwell here from the Institute for Harmonious Science, and today from the foot of one of the most iconic rock formations in the whole of Britain. Haytor is probably the best known, certainly the most visited landmark on the whole of Dartmoor. Two massive slabs of granite, each weighing in at several thousand tons. They are quite literally rock hard. And I'm here to tell you today that they are, like everything else in the universe, made of light. Seems pretty unlikely, doesn't it? I mean, light is hitting us all the time, at very high speed, the speed of light, and we don't even feel it. But if somebody were to throw a rock off the top of Haytor and it were to land on you, you would certainly feel it. It could well kill you. So how does that work?
Well, if we take a photon of light, or radio wave or X-ray radiation, they're all variations of the same thing, and we wrap it round into a ball, it takes on some interesting new properties. First, the electric and magnetic fields forming that photon, or packet of energy, could act across the closed loop and hold it in that circular path, so it stayed in that form. Just after the Big Bang, when the whole universe was packed into a space much smaller than even a single atom, all those countless photons of primeval energy would have been twisted around on themselves into all sorts of configurations. It's more than possible that some of those coiled up photons, say one in every few billion, would have set into self-perpetuating closed loops that we now call particles. This fits with the observation that there are around 10 billion photons for every elementary particle of matter in the universe today. Second, because light waves are spread across space, not just thin lines, there would be effects spreading out across space from these closed-loop light waves too, as a result of their electromagnetic fields. We experience those effects as electric charge, positive or negative. More on that in a moment, on every elementary subatomic particle. Third, because they have those charges, these particles will seem to be solid, quite unlike light as we think of it. Let's just take a look at a couple of atoms made up of particles formed from these closed-loop light waves. We'll skip the detail of the nucleus or core of each atom and just note that every atomic nucleus has an overall positive charge. This means that electrons, which each have a negative charge, will be attracted to the nucleus and orbit around it. Opposite charges attract each other, like charges repel each other. Electrons are shown here as closed-loop energy waves, coloured orange to show negative charge effect. The nucleus is green to show positive charge effect. If we now bring another atom alongside, we can see that the electrons orbiting around each one form a sort of shell of negative charge around the nucleus. And of course when those two shells meet, they'll repel each other, because they're the same sort of charge. So, for example, if a granite rock were to fall off Haytor onto, say, a sheet of glass below, then the electrons around the atoms in that granite will repel the electrons around the atoms of the glass. In other words, the atoms in the granite push the atoms in the glass away, very strongly, because granite is very hard. The atoms in it are packed together very firmly. You don't need to be told what that does to the glass. There's a bit more to it than this, of course, because atoms do sometimes join together to form molecules, like the molecules in the granite and in the glass. But this repulsion principle still applies to those molecules. Molecules have a sort of electron shell around them, just like atoms do.
Okay, so we've seen that even light can smash windows if we wrap it up in tiny bundles. Let's look at other evidence for this particular view on particles of matter.
One real giveaway is the matter of antimatter. For 80 years now, the scientific world has been puzzling over why the universe is almost totally conventional matter, with just tiny amounts of antimatter here and there. One of the physicists who received a Nobel Prize in 2008 for his discoveries on this issue said in his presentation, we still don't know why there's so much more matter than antimatter in the universe. But if we just take on board that matter is formed from closed-loop photons, then the reason sticks out like a sore thumb. It's a done deal. It's screamingly obvious why there'd be this imbalance. That massive clue, sweeping like a searchlight through the whole of the cosmos, is looked at in detail in my presentation on this subject, the right-handed universe, as well as a scientific paper, on my website, transfinitemind.com. Another big clue is the fact that when a normal particle and its corresponding antiparticle meet, they annihilate each other, leaving just a couple of linear photons heading in opposite directions. Just think of two snakes, each in a closed loop biting their own tails, spinning through space at high speed, one clockwise, the other anti-clockwise. If they smack into each other, their opposite spins cause each one's tail to be knocked out of its mouth, and they go flying off in a straight line in opposite directions. That's pretty close to the photon-particle picture of matter-antimatter annihilation. The opposite's also true. If two photons of just the right energy meet from opposite directions, they can turn into a particle and an antiparticle. Here our two linear snakes hit each other on the nose just enough to set them both spinning, and presto, two closed-loop snakes, aka particles. These switches from particles to photons and back are both well-established scientific facts.
It's really not rocket science, just applied common sense. If two particles can turn into two photons, and two photons can turn into two particles, what else can they be but just different versions of the same thing?
The real buzz, though, comes when we start looking at relativity theory. Einstein made a giant intuitive leap when he formulated his special theory of relativity. The closed-loop photon theory of particles provides the structural basis for that leap, giving a clear physical and mathematical derivation for all of the proven findings of special relativity. It also gives a thorough explanation for findings of general relativity. See the video, How Gravity Works. Let's look, for example, at the idea from relativity that time goes slower for something that's moving very fast. If we think of a particle as a photon going round and round a closed loop, when that particle is moving, then that closed loop becomes a spiral, round and along at the same time. This means that every loop takes longer, since that photon is travelling further each time around the loop, along as well as round. So it does less loops each second. Since the effects of time must be carried by the energy flows that make up every object, there is nothing else, those effects won't be passed around an object so much when it's moving fast. Less energy loops per second. So the effects of time will take longer to take effect in a fast-moving object. Time acts more slowly for that object. Relativistic time dilation sorted. This explanation fits the maths exactly. The biggest finding in special relativity, of course, is that the speed of light is absolute, or at least it seems to be. That's all sorted too, when we look at matter as closed loops of energy. First, as we've just seen, particles moving fast will experience time as going slower. If we look a bit deeper, we also find that moving objects experience everything slightly differently. For them, time and space are both tilted by the slope of those spiral energy flows. Put those effects together and there you go. Anything going at light speed does seem to have those unique properties. That's because the energy flows that make up the observer, or the measuring device, are going at light speed themselves. The maths works out beautifully.
Special relativity also tells us that things get heavier. They have more mass, effectively, as they get faster. The maths all works out perfectly for that too. those increased energy flows give rise to the effects of increased mass. In fact, all the effects of mass are actually caused by those energy flows.
Of course, the most well-known equation in the world is Einstein's E equals mc squared. This links the energy held in an object to the mass of that object. Mass and energy are two sides of the same coin.
The closed-loop photon description of matter leads directly to that famous equation in just 4 lines of high school maths. Those 4 lines are printed in my paper on elementary subatomic particles, referenced at the beginning of this video and also on my website. You can actually get a free copy of that paper if you buy any of my books.
We could look at quite a few other things, like, for instance, experimental evidence that an electron is energy circulating at light speed. But you're probably beginning to get the picture. We've known for over 80 years now that matter has wave-like properties. The evidence now for particles of matter being closed loops of electromagnetic energy, light and the like, is so strong that it's hard to imagine any scientific basis for believing that they're not. As a bonus, this view overcomes all sorts of contradictions, like the apparent impossibility of black holes according to relativity theory, as well as opening up a lot of exciting new research opportunities. It also raises some interesting thoughts on what we, and the universe, might be all about. In closing, it's worth noting that all of the concepts discussed in this video have been endorsed by expert peer review and publication in a systems sciences journal that's well established internationally as a scientific citation reference. Check out the websites.